Alright, so hopefully you worked on numbers 7 through 10 and you have answers for all 4 of those questions. We're going to move on now and just kind of build on the idea of fractions as exponents in talking a little bit about how we can transfer between radical form and our exponential form. And we can do that by kind of building on this concept. I'm going to give you 2 examples that we're going to talk about before we work on example 4 together and talk about a couple properties. So starting off, if I kind of build on this concept of how we transfer between radical form to exponential form, if I gave you the cube root of 2 raised to the 4th power, there's a couple things that we can do here. We can rewrite the inside of the parentheses to be 2 to the 1/3 power, just like we talked about before. But now we have an outside number other than 1. Okay, and so how do we deal with that? Well, if that outside number other than 1, if we write that as a fraction, let me slide this up. I don't know if you guys were able to catch that in talking. Let me go back over that real quick. We're taking the cube root of 2 and we're raising the entire grouping to the 4th power. So if we rewrite that in exponential form, we get 2 to the 1/3 power, and then we're going to rewrite our 4th root, or our 4th power on the outside as a fraction so that they match in format. And if we do that, we get 2 to the 1 times 4 is 4 over 3 times 1 is 3. So we can rewrite our radical, this is what we call radical form, and we can write it as an exponent. So they mean the same thing, but they're in 2 different forms. We've got radical form over here, and then we've got exponential form over on the right. Let's do another example. Let's say we had the 5th root of 9 raised to the 7th power. Okay, so how are we going to write that as an exponent? Well, the first is we can actually take the inside of the parentheses and write that as an exponent first. So if we do that, remember our index goes in our denominator, our radicand becomes our base, so we get 9 to the 1/5. That's all raised to 7. If we write that as a fraction, we get 7 over 1. Multiply across, we get 7 over 5. Got our exponential form, our original radical form. Once you guys get more comfortable with this, you'll be able to jump back and forth between them, because the outside number always goes in our numerator, the inside number always goes in our denominator, and our radicand is always our base. Okay, so let's build on example 4 and our rational exponents together. Couple properties that are important to know. If I have some value a raised to the m over n power, we can separate this as the m comes out, so this is the same thing as n to the 1, or a to the 1 over nth power raised to the m. And this is the same thing as, if we rewrite this as a radical, we get our denominator is our index, our base is our radicand, all raised to the mth power. So it's just like the examples we talked about before, just in a more general form. Lastly, if we look at our negative, the difference between these two is that our second one has a negative, and our negative, all that means is, this was originally over 1. The negative just means we're going to take our entire numerator and put it in our denominator. We're just going to flip it. So 1 goes on top, a to the m over n. Our negative drops out when we move it. Just like up top, this is the same thing as a to the 1 over n to the mth power, which is the same thing as our index goes on, is the same thing as our denominator. Our base is the same thing as our radicand, all raised to the m. Is this important to know and memorize? Not necessarily. As long as you can use it in your examples and you understand how to transfer between both forms, That's all we're looking for. We're never going to need you to write back these rules for us, as long as you know how to use them. So let's talk about example 4 and make sure that we understand what we're being asked and how to use these properties of the radicals and the exponents. In example 4, they want us to rewrite the expression. So it's important for us to know our directions, and our directions are asking us to rewrite expressions here. So in letter A, we obviously have a radical form, and we want to change it and rewrite it into a rational exponent. Okay, so we want to take our radical form and change it into our exponent. So let's do that. So down below, we're going to deal with our parentheses first. So the 4th root of 5, we can rewrite this as our base is the same as our radicand, so this is the same thing as 5. And remember, this is 1 over our index, which is 4, so this is the same thing as 5 to the 1/4 power, raised to the 3rd power. So put this over 1. It's the same thing as 1 times 3 is 3, over 4 times 1 is 4. 5 to the 3/4 power is the exact same thing as the 4th root of 5 raised to the 3rd power. Okay? Difference is this is in radical form, this is in rational exponent form. Let's look at letter B. Letter B has us in radical form, obviously, because you see your radical symbols. We want to write it in rational exponents. So we're going to deal with our denominator. This is the same thing as 1 over, well, our index is 6, and our radicand is 4. So our 4 becomes our base, our index becomes our denominator, so this becomes the same thing as 1 over 4 to the 1/6 power. And we can condense this one more time because it looks funny leaving it as a fraction. If we move our denominator up to the numerator, we can do that, but we have to add the negative back into our exponent. Because remember, the negative with our exponent means we can flip our numerators and denominators top to bottom. So we can actually rewrite this as 4 to the 1/6 power with a negative out in front. So our answer should be 4 to the negative 1/6 power is the same thing as 1 over the 6th root of 4. Same thing, mean the same thing, radical form, exponential form. In letter C, they want us to rewrite 7 to the 2/5 using radicals. So in letter C, we're going from exponential form to radical form. Alright? So let's look at this and break this down. So we've got, obviously, our denominator is 5, so we know our index is going to be 5. Our base is 7, so our radicand is 7. And our numerator is 2. And our numerator, again, if you translate it, is the entire group raised to that power. So the whole group is getting raised to the 2nd power. So 7 and 2/5, or 7 to the 2/5 power is the same thing as the 5th root of 7, all raised to the 2nd power. Let's look at letter D. Letter D has 2 and negative 2/3 as an exponent. We want to change it to the radical form. So we're going to deal with this. We're going to kind of separate it out. We know that our index is 3 because our denominator is 3. Our base is 2, so our radicand is 2. And we're raising this whole thing to the negative 2 power because it's negative up top. So we can go one more step, get rid of that negative if we want, and we can put the whole thing in the denominator as the cube root of 2 squared. So 1 over the cube root of 2 squared is the answer for letter D. Okay, so let's look at example 5. We're going to build on this one more time, and then you're going to have a chance to do a couple more problems on your own for numbers 11 through 19. So in example 5, we want to evaluate the expression. So in this case, we actually want to evaluate. Evaluate means we want one final answer. So we're not just rewriting things, we actually want a final answer, one final answer. So let's look at example 5. So we have it in exponential form. It may be a little bit easier to look at if we change it over to the radical form. So let's do that. Let's change it first to the radical form. So here you have your index of 2. So you're taking the square root, your base is 4, so you know your radicand's 4, and you're going to raise this all to the third power. So let's break this down. Well, this 2 out in front doesn't really mean a whole lot because we can kind of erase that and it means the same thing. So we've got the square root of 4, which we know is 2. 2 to the third power we know is 8. So 4 to the 3/2 power is the same thing as 8. We're actually going to evaluate and get a final answer. In letter B, if we break this up into our radical form, our denominator is 3, so we know our index is 3. Our base is 8, so our radicand is 8, and we're raising the whole thing to the -2 power. So if we do that, we can separate that up. We know that the cube root of 8 is 2, so we get 2 to the -2 power. The negative as an exponent means we're going to flip it in our denominator and drop the negative. So this becomes 1 over 2 to the 2nd power, which we all know is 1/4, for example 5. Okay, so I'm going to give you guys some time to work on numbers 11 through 19 on your own and see if you guys can come up with your own answers for that. We're going to meet back in a couple minutes and go through our group warm-up part 2, which has about 5 parts to it, and talk a little bit about some more properties of our radicals and exponents. So take this time now for numbers 11 through 19, and we'll meet back in the next video.